Before we start defining intelligence and artificial intelligence, I will ask you about those sample problems or sample situations. And I will ask you, what do you think? Does solving such tasks require intelligence or not? What's your casual, instinctive feeling about it? Timetabling is like building a timetable, for example, for your studies. When you have groups of students, you have some rooms, you have teachers, and you have to match everything together to build a schedule. Playing chess, everybody knows what's playing chess. Proving theorems refers to what you probably were doing during your logic classes. So you have like a logician or mathematician, and they're supposed to prove some theorem. Does it require intelligence or not? Then we have another example of autonomous mobile robot control. So we want to have a robot which is not familiar with some environment, and this robot is supposed to fulfill some tasks. For example, find sources of energy and survive for a longer time. Maybe perform some specific task, like we send this robot to Mars or to some other planet, and we want it to do some job for us, and we are unable to control it, we are unable to communicate with it in real time. So would it require intelligence or not? Medical diagnostics, so diagnosing patients, and planning in general. This one is more or less similar probably to scheduling and timetabling, but planning understood more generally. Like we have a very complex enterprise with many stages, like we are building some huge road, for example, like a motorway, or we are building huge complex of buildings, and we want to plan everything so that the cost is minimal and the whole job is finished as soon as possible. So do you think such tasks require intelligence or not? Or are they too easy or too mechanical?
Pause the video and try to answer this question.
It's not a tricky question.
They need, yes. Yes.
You think they require intelligence? And any other opinions? As I said, it's not a tricky question. It's like referring only to your intuition. How do you feel?
I think it don't need intelligence.
It doesn't need intelligence.
It could be done with some algorithm or artificial neural networks without intelligence.
That's a good point. That's a good point. By this I mean, when I asked about intelligence and you said intelligence is not required because this could be solved by algorithms, does this mean that algorithms equal no intelligence?
No, it depends how we...
Could intelligence be
Is intelligence just some algorithms? Not just...
Maybe not just. I mean, is it bad? But yes, it's true. This is the question, whether intelligence could be expressed by some algorithm. And you seem to downplay it. You seem to say that it doesn't require intelligence because those tasks could be solved by an algorithm.
I think that artificial intelligence is like the algorithm is like different than the intelligence of the human. So maybe that's why, for example, I thought the same as my friend, but I said yes and he said no.
So you think the same way, but your friend considers algorithms insufficient to speak about intelligence, and you say that it's okay, that intelligence could be expressed by some algorithm.
I think people intelligence is just like thinking
abstractly.
And that's why it can solve all these problems.
A human can solve, or?
No, machine.
Machine can't solve those problems. And which problems machine cannot solve from this list?
Proving.
Proving theorems.
I don't know. I think about more than this is.
Because it's just like 6 examples, we definitely could have much more.
But I don't know if you heard about something, I don't know, a month or 2 months ago, about the program which is solving the problems in chess. It's called AlphaZero, and this new program beat the best chess program, which was like
Stockfish.
Stockfish, exactly. And this program was he was like playing chess for 4 hours.
Speaking about one of those milestones, actually the most recent milestone in AI, I want to ask you about other milestones that you may remember. Some moments in time when something happened and people thought, artificial intelligence is closer than we thought. Some achievements of AI from the past. Very famous achievements.
Pause the video and try to answer this question.
Kasparov. So playing chess. It was 97 probably, quite a long time ago. So Go, you mentioned. It was when?
2 years.
2, 3, 4 years ago. Okay. So Go, do you know the game of Go?
Yeah.
That's good. So the game has simple rules, but is very complex for many reasons. What was the name of this computer who won with Kasparov? Deep Blue. And with Go, you mentioned AlphaGo, AlphaZero, AlphaGo Zero, okay. Any other examples of milestones and achievements of AI?
Maybe something like the intelligent building or...
Intelligent building, what would it be?
It's like controlling all the things at home, like the lighting or...
And where is this intelligence in the intelligent building? Where is this most intelligent part? Because when you say it detects when people are inside, it's just like a simple sensor, right?
Yeah, but there's like a computer which is like controlling everything.
So it has some rules, but again, rules, they may be like a mechanical rules. If somebody is at home, then turn on lighting. So it's not that intelligent, right?
No, because when I'm not at home, I can ask my computer to have like lights on or something, so that the thief doesn't know that I'm outside or something.
Yes, but it's still like you are designing rules.
Okay,
So it's very simple, we would say. I mean, it's nothing intelligent. So where is this intelligence? Or this is like a business term, intelligent home. So that people buy some product which is intelligent, like intelligent washing machine, for example. Maybe there is nothing really ambitious and intelligent inside, just a set of rules. And here we touch again the same issue, where intelligence starts. To which point we can say that this is just a simple set of rules or a simple algorithm, as you mentioned, and then there is this magic happens and we start speaking about intelligence. Okay, what about other milestones?
I don't know, Cleverbot maybe, but I'm not sure.
Cleverbot. There was a bot which was doing what?
Collecting data.
Collecting data.
I think people was talking with him and he just repeat their answers.
Probably the first famous bot was Eliza. You know this story? Like the beginnings of AI. But speaking about talking bots, there was a very famous example a few years ago of a big company creating a bot which was interacting with people over the internet, and it learns too much from these conversations. So what was the name of the bot? And the company was Microsoft.
A few months ago, Google's neural network has created another network.
So neural networks learning themselves to build other more efficient neural network, for example. Okay, so it's like learning to learn, definitely. We will talk about it in the future a little bit as well. There is a quiz in television, quite a difficult quiz, where participants, in order to win the quiz, they actually need to ask questions. They are asked questions, but they do not answer them like in plain text, in sentence, like an answer. They also need to ask a question. A quiz show. We have this in Poland under a different name. It's very popular in the United States. And there is also a big company behind the computer which won with the best humans in this quiz. In English, it's Jeopardy. Does it ring a bell? No? And the company was IBM, but IBM Watson? No? Nobody heard about IBM Watson? So this is another milestone. You should have heard about it probably. What is your interaction with artificial intelligence? What devices, for example, do you interact with that you believe have some artificial intelligence inside?
Pause the video and try to answer this question.
And autonomous cars, do they require intelligence? Not really, no? Driving autonomously in the city, no? So we have Deep Blue, we mentioned this. We have DARPA Grand Challenge. That's the Defense Advanced Research Project Agency. They had this competition for cars to go to the desert, and it was mostly failed I think in 2004, and it was mostly successful, and most cars passed this test in 2005. So it was just 1 year between complete failure and mostly success. IBM Watson, deep reinforcement learning for video games. Maybe you have heard about it, that there was an algorithm from this DeepMind company, which was later bought by Google, which was able to learn to play actually almost any video game. I think they tried with Atari video games, and what was special was that this algorithm, as an input, only got raw pixels from computer screen. So it was like an input to this algorithm. Then we had this algorithm, and the algorithm was controlling the game by, for example, pressing left, right, and fire, or some other button. So the algorithm had to learn itself how to play any game based only on the screen and on the pixels, and it was observing and paying attention to the score. So, you know, in top right corner you usually have the score displayed. So this algorithm knew when it was doing bad and when it was doing good, or when it was successful. And it was learning in this closed loop. So this is like a huge gap between raw pixels and the concept of the game and what you have to do to increase your score. And what was so powerful in this achievement is that there was no background knowledge input into this algorithm before. So you could actually try this approach with almost any game. We will not be talking so much about deep reinforcement learning because, again, no time in this course. But we will be talking about, for example, neural networks a lot, and maybe a little bit about reinforcement learning as well. Then AlphaGo Zero, we covered it. Autonomous cars I mentioned, and they as well. Okay, so what is intelligence? You probably can define it better than me. Can you either make up some definition or maybe cite some existing definition from somebody else? What is intelligence?
Pause the video and try to answer this question.
So there are many definitions.
Yeah.
Computational intelligence?
Many various intelligences.
Various intelligences. Various kinds of intelligence. Mm-hmm. Like emotional intelligence, recently popular. Social intelligence, computational intelligence, as you mentioned. Okay, so let's define anything. Let's define any of them. Let's be a little bit more precise. What about this intelligence test that we are taking from time to time? Does it measure any specific kind of intelligence? What kind of skills?
A lot of skills.
A lot of different skills.
Depends on the definition of
Logical thinking or something.
So you say logical thinking. This is what this test mostly measures.
Intelligence is a way of solving different problems in complex environment.
What a nice definition. So intelligence is a way of solving complex problems? Solving problems in complex environments. Solving problems. Does it bring us closer to our precise definition? Solving problems in complex environments. So what is required for intelligence? Are there any features or properties that a human or some living animal should have to express intelligence?
Pause the video and try to answer this question.
Knowledge, okay. Abstract thinking, you mentioned it before. And thinking, not even abstract, but thinking. And what is thinking? Could we say that it's like information processing, some way of processing and changing representations of information, okay? Learning. Language, communication. But is it like mandatory or optional? Can we speak about intelligence without language and communication? You say no, I say optional.
It's optional to communicate.
It may help, but may not be necessary. Okay, what else?
Making a reaction for environment.
Reacting, environment, okay. Again, is it required and mandatory or optional?
I think optional.
Optional. Maybe some kind of environment, not necessarily like our physical world, but some kind of environment. Anything else we didn't mention? Memory, is it required or not? So we have a list. I have put a list. Knowledge, inference, perception, cognition, learning, generalization, adaptation, creativity, emotions, intuition, neurons, embodiment. Embodiment is like this environment or having a body to interact with the environment. But we didn't mention, you didn't mention at least, we didn't discuss creativity.
like abstract thinking.
Abstract thinking, creativity, okay, because there is no abstract thinking on my list. Emotions, helpful or not? Maybe not helpful at all. Intuition, what is intuition? I was recently discussing with philosophers about intuition.
Intuition basis for generalization, I think.
Is it something?
Own experience and knowledge.
Neurons. Do we need neurons for intelligence?
Pause the video and try to answer this question.
Your faces reveal what you are thinking. Your doubts. First of all, what kind of neurons? I mean biological neurons, or maybe we could build computational models of neurons. Some kind. So neurons is like a processor, like something which does the work. So we probably need some kind of units. It could be like CPU, like computer processor, for example. But we need something to compute. Also, our world itself can compute. So some particles can self-organize, for example, and this can also do some useful calculation or computation. Okay? So how to define artificial intelligence? We struggled a little bit to define intelligence. You mentioned this ability to solve problems in complex environments, which is a little bit vague. I would say it's not very precise. And it would be very convenient to say that artificial intelligence is like intelligence, but just artificial. This way we are escaping this problem of defining intelligence, because we say, okay, so those guys, let them define intelligence like cognitive scientists or psychologists. They should define what intelligence is, and we are just making it artificial, which means that we are just implementing it in some artificial medium. and otherwise nothing changes. Also, artificial intelligence is sometimes defined as some ability to solve problems, and this is again escaping the actual definition. It's the ability to solve problems which would require intelligence for a human to solve. So if there is a difficult problem and we agree, like this is why I was asking you what you think about those problems, and do they require intelligence? So if we agree that some problem requires intelligence to be solved from a human, then if we have some artificial machine, for example, or computer, or artificial design which solves the same problem, then we would agree that this is artificial intelligence. Okay? So this is like a definition which resorts to another definition. And despite this maybe deficiency, that this definition is not self-sufficient, it refers to another definition, it is still quite practical, this way of defining artificial intelligence. And did you hear about strong AI and weak AI? This split between strong and weak is common, and it's often used, not only for AI. So strong AI is like expecting AI to really resemble human intelligence, whatever it is. And it is often said that people who expect strong AI will be always dissatisfied, because they will always say, but okay, you build something cool, it works, it's useful, but it doesn't work like a human. For example, it doesn't have this abstract thinking or background knowledge or whatever, or adaptability. So this is this stronger point of view on AI, and those people usually say that we won't have stronger AI for many years, and you can put any number like 20, 50, 100, 500 years in the future. We won't have strong AI, which is probably not correct anyway, but I'm just saying that this is this strong point of view. And weak is just a practical approach. We want AI to help humans, to help us to solve difficult problems that we know and we agreed that they require intelligence from humans. And if we are successful with this, then we are happy and we say, okay, this is AI, because we have this weak point of view on AI. So we consider anything that solves difficult problems for humans, which require intelligence from humans. If it's artificial, we consider this artificial intelligence. Let's think about this difference between humans and machines, and what computer does well and what computer is not good at.
Computer is good at computation.
Computer is good at computation, hence the name, and human is good at humanation, hence the name.
Computer calculates much better than human.
So calculation, computation.
Computer is faster.
Faster, but in what? In everything?
No, but
It doesn't run so fast. Usually. But those robots from Boston Robotics, human is better at sport, okay. Mm-hmm. Let's try some example which should be preferential and beneficial for computers, which would be calculation. Let's do some comparison. Let's think about calculating a product of two numbers. Any numbers, not so big. Maybe it's large for a human, but you still know how to do it on paper, right? Because you were in school and they taught you how to do this on paper by multiplying individual digits. So let's try to tell how much time would it take for a computer to solve and how much time would it take for a human to calculate the result. Let's start with a human. Roughly
1 minute or 2 minutes.
So let's say 60 seconds, rough estimation for a human. without any special training. And computers? You said milliseconds. Let's try to be accurate. You know that computers have processors, like this, right? This is CPU, central processing unit. This CPU is actually quite small. Do you know how big it is? Physically? But you can imagine this chip and how big it is on the board, like a few centimeters. So this may be like this size, and actually the chip itself is much smaller. It has many connections. So it may be like 1 centimeter. And this chip has something very important, which is a clock. A clock is something which generates some synchronization signal for other parts of the chip to work together. So what is this frequency of the clock in modern computers, in modern CPUs? It's expressed in hertz, gigahertz. How many? Typically 2 gigahertz means how many beats per second, or how many impulses per second? You said 2 million? Billion? So it would be 2 times 10 to the power 9? Yes, you agree? Because we have kilo, mega, giga, right? So this is so many impulses per second, which means that the distance between 2 impulses is really, really small. And now the most important question is, how much time does it take? How many cycles of the processor is required to calculate multiplication of 2 integers? What do you think?
Pause the video and try to answer this question.
The processor actually needs to implement some kind of an algorithm to do this calculation. And we could assume, it's not entirely precise, but we could assume that for integer multiplication, it's like only one cycle. It could take more, but contemporary CPUs are very smart and they are doing many things in parallel. So they can start many tasks, one after another, and then those tasks will be complete again one after another, but they will be executed in parallel. So we could roughly say that it's like one cycle. So we have 60 seconds for a human, and 1 divided by 2 times 10 to the power of 9 for a computer. So this looks like a huge difference, right? Like 9 or 10 orders of magnitude faster. So this is really incredible difference on this specific task of calculating multiplying numbers. Of course, we could make it less favorable for a computer, but still, probably, as you mentioned, computers are much better than humans in calculations. Is it possible to further increase this frequency of the clock? Because you could imagine that earlier computers were not that fast. Computers could have like 4 megahertz of frequency, and earlier kilohertz. So now we have gigahertz, and can we go further and increase this frequency even more to make computers faster?
Yes, but I think there is some border.
Some limit, some border. Is it far away, this border? When you buy a computer, does it have one CPU inside or many CPUs? That's a tricky question. How many CPUs are in your smartphone? Who knows? And you know this term core? So core is more or less like a CPU when we are speaking about this organization of computers now. So how many cores do computers have? 2, 4, 6, 8, and more, 16 and 32, and any number, and maybe 1,000. Computers have many cores, and they do because we are actually unable to increase this frequency significantly. Maybe a little bit, but it's no longer practical to increase this because all those paths in the CPU when the current flows are already so tiny and so thin that electrons do not want to flow through them very efficiently. They like to jump. There are some quantum effects. It's all already so tiny that we shouldn't expect so much progress in making it much smaller and more energy efficient. Of course, there is a lot going on, and maybe there will be some breakthroughs in the future, but for now it's much easier to simply produce more and more CPUs, which are not faster. So you have, for example, 8 CPUs in your smartphone or in your computer, and all of them are clocked with this 2 gigahertz. So what's the gain when you have many cores and they cannot be made faster, but there are more of them? You have to design algorithms so that those algorithms use this distributed power or parallel power. If you have a sequential algorithm, a sequential means if you have an algorithm that has instructions which must follow one after another because the next instruction uses results of the previous instruction all the way, then you unfortunately are unable to make it parallel, and you can wait for many years, but if this frequency will not become higher, then your algorithm will not run faster, will not complete faster as well. Okay? So now the big thing is to design all algorithms so that they use this parallel power of computers, of many CPUs. So this was one very unfair example for humans, like this multiplication of numbers. Yes?
I think computers are bad at recognition.
Computers are better at recognition. Recognizing what?
Animals or emotions, other people.
Are they bad or no longer bad? Not as good as humans, you mean? Okay. And what about memory? Because we spoke about this raw processing speed. What about memory? Memory capacity. Could we compare memory capacity of a human and a computer? How many pictures can fit into a smartphone or memory of a computer? In computers we have this RAM, random access memory, and we have hard disks and solid state disks and things like this. So can you give me some estimate of capacity for RAM? This is this fast memory of a computer. How many megabytes, gigabytes, terabytes? 4 gigabytes. And our slower memory disks? Okay, let's put this 1 terabyte. And now we have an image, like we took our smartphone and took a photo. What's the size of the typical photograph? JPEG? 5320. So how many JPEGs would fit into our RAM? Oh, let's make it 4 for easier calculation. Only 1,000? So not that much. And on our disks, if our disk were 4 terabytes, then it would be 1 million, right? 1 million photographs. And what about humans? We have a lot of pictures in our brains when we think. Is it even possible to estimate what's the capacity of human brain in terms of bits or information?
Pause the video and try to answer this question.
It's difficult and requires a lot of assumptions to do. There are some publications which try to estimate it. But definitely there is no comparison because computers remember everything so perfectly, right? All the pixels or some descriptions of pixels. Of course, in JPEG we have a lot of compression and it's not so easy just to represent every pixel and red, green, blue of every pixel, but still the way computers remember JPEGs is very, very different than humans. On the other hand, we will talk about neural networks and some models of neural networks which actually resemble the way humans remember images or pictures later on. So you will learn how to store pictures in computer memory in a completely different way than they usually are represented. There is also one classification of AI different than strong and weak, and quite popular as well, general and narrow. And I think you intuitively understand what's a narrow AI, what's a general AI. So narrow is just for a specific task, and general is general, as the name says. And most people say that we still don't have general AI, but we are definitely progressing in this direction. So our artificial intelligences become more and more general. And there is also another term which you probably heard, which is superintelligence. Did you hear about superintelligence? So superintelligence simply means that it is higher level or more advanced than casual intelligence or standard intelligence, maybe even more general. This notion of superintelligence refers to the fact that we could imagine we have an axis of intelligences, and we have simple animals, we have humans, we have current artificial intelligence which progresses in this direction, and we expect that at some point this artificial intelligence will exceed the level of human intelligence and will go faster and faster probably in this direction of more advanced intelligences. So this would be superintelligence or transintelligence. Something above humans. And what do you think will happen when this event takes place? When artificial intelligence exceeds human capabilities? What will humans do? Any predictions?
Pause the video and try to answer this question.
I guess it won't be possible at that point to turn off the internet, and maybe artificial intelligence will not be dependent on the internet. Will it be good or bad? What do you say? For humans, you say good. You're an optimist.
So it will be good for Earth.
It would be either very good or very bad or something in the middle, and people generally have no idea. But what will happen with humans specifically? You can assume it even today, that if you had a computer which was 1,000 times smarter than you are, how would you feel? What would you do? How would your life change?
Maybe we will be like a god for these robots.
But those robots would be more perfect than we are, or more intelligent, right? So this is not really like about being gods. Maybe like being fathers or mothers, but regarding gods, it doesn't work because they are more perfect. And once we created them, or maybe actually we can create something which is less advanced than us, and it will start, like you mentioned, this neural network which designed another neural network. So it will start improving independently of us. So the question is whether we will still be gods if this will be much more advanced. We definitely will be designers or creators, but not necessarily gods. I say this because when I see this picture and I see intelligence here and intelligence here, I would say that we think about this intelligence as God, and not it thinks about us, God, because we don't understand it and it understands everything about us. It knows more, it has actually more of everything that we mentioned here. So probably we are looking up to this intelligence as to God. But how would your life change?
But how is it possible if this superintelligence, we create this superintelligence and it's super? I think we know everything about this intelligence because we make it. So we know how.
So would it look, but it's not true. Because humans can easily create things that are beyond their comprehension, even though they build them. When you write a program and give it to a friend, and your friend is unable to understand this program, right? You can imagine that you write a program which develops itself. And after a few hours, it's like trillion lines of code. So you created it technically, right? But you have completely no idea what's going on. But magically, this code works perfectly. Like you ask it any question and it gives you the proper answer, but you no longer understand it, right? So this is tricky, but this is the truth. We can create things that we don't understand how they work, but they still work perfectly well and even better than us. Like, for example, this computer which won Go game or chess game, right? Who created this algorithm? Humans created it. But they cannot understand how it plays Go. And it plays Go objectively better than anything else. So this is an analogous situation. But this was interesting. I want to listen to you. How would your life change with this super intelligent thing? Would you ask it any difficult question you have? Because you would know that it will give you a correct answer.
Yes, I think that we should listen the opinion of this computer.
I don't think so.
It's like having somebody wiser, right? Who is always right, unfortunately.
Some computer doesn't have like emotions or the experience.
Doesn't have, or we don't want it to have, but it could have emotions if you want it.
But the superintelligence could understand our emotions.
Okay.
And again, it could. If we want it, it could.
But only
Actually, computers now can recognize emotions better than humans.
you mean like the body language or?
Body language, facial expression, whether somebody lies or not.
But they can like understand the feelings of being hurt or something. Like they can understand how not.
Yeah, but it's today. It's not a problem in the future at all. And again, we usually want computers to be those emotionless machines for practical reasons. We don't want them to get emotional too much. So it's not like we can't do it, we don't want to do it, but we could. Oh, you may ask, what is this rabbit doing here? I think it wants to take us into a rabbit hole. So let's go there. Assuming that superintelligence is created, I mentioned that some people are optimists and expect huge gains for humanity, while others are afraid of the worst, like for example conflicts between human and artificial intelligence, where the latter is superior. Another group of people expects humans to merge with AI. This will obviously happen because this already happened to some degree. We use smartphones and the internet to augment our intelligence with AI from the cloud. Many people consider this merger scenario to be safe and positive. But I would like you to consider this. Instead of human intelligence and artificial superintelligence, imagine simple animals like ants, bugs or rabbits, and humans. Humans are considered superintelligent by rabbits. Imagine 1 billion of rabbits wants to merge with one human superintelligent brain. They will succeed But how much of the rabbit nature will remain after such a merger? How much use will have this human brain from the brains of 1 billion of rabbits or 1 billion of ants? Sure, it will be safe and rabbits or ants' consciousness and memories will survive, but this kind of a merger will rather be an incorporation, and these smaller, less intelligent brains will lose their identity if they want to understand and become one with the more advanced intelligence. Their abilities will be devalued when the superintelligence is available.
Sorry, I have a question. Because we talk about this Go and the superintelligence.
Yes?
Maybe just because computers are faster than us, they can learn faster, and if we have enough time to learn, so we could be
Yes, yeah.
good as
Yes, you are touching on a very important thing here and issue regarding time. If you had somebody who was identical than you, but his brain or her brain would simply work twice as fast, or 10 times as fast, or 1,000 times as fast, you would consider them like God or much wiser than you, but their brain wouldn't be different from yours. It would just work faster. No more neurons, no different architecture of the brain, only faster. So it would only have more time to think. And the same thing, if you merge many brains, many human brains, the totality of humanity is wiser than a single human. So it's like, actually what you said about this speed and what I said about this merging, this also means that when you are progressing on this axis of intelligence, it may be sufficient to only produce faster computers, and it may be sufficient to only produce more CPUs and more processors. It doesn't require some magical new architecture of neural networks or computers. So it's not necessarily quality, it could be just quantity. This is also something you could or you should think about. Okay, expert systems. Expert systems are like formalizing human knowledge and representing it in the computer, and then the computer or the algorithm does the inference. But the inference and thinking within those rules is only limited to this set of rules that humans put in the computer. And why it is called expert? Because this knowledge, this expertise, comes from the experts, like from medical doctors or maybe some technicians which repair washing machines or repair cars. So you go to a person who is an expert in their field and you ask a lot of questions. Why you think so? What would you do in this situation? And you represent everything as a rule in a computer, and then the computer follows those rules. So the computer becomes, or the algorithm or the program becomes an expert in some narrow field. And I will not be talking about it because it's not along the lines of modern AI. We would rather expect machines to learn. We talked about machine learning, right? We would prefer machines to learn. It's not ambitious enough to talk a lot about it in modern AI course. So when we look at those points, those examples here, we see that more or less they regard searching through many possible combinations or configurations, inference, like with these proving theorems maybe, and learning or adaptation. And when you think more about those three fields, you will discover that actually all of them can be considered some kind of a search. So we have many possibilities, and you are looking for the solution, or you are looking for the best way to solve some problem. And this is not how humans solve things, usually. Usually humans do not imagine all possible solutions and then pick the best one. But computers can do this because they are so fast. So computers can be, in a way, stupid and use their high speed to still compete with humans, but in a completely different way. But this can be misleading, what I said, because I said computers can be stupid. But fortunately or not, one of the solutions that we are looking for in this huge search can be, for example, a structure of a brain. So you could think about your problem, not like, for example, I want to find the shortest path from A to B. So that's like a typical routing problem. You use your navigation, your GPS, and you are looking for the shortest route between 2 points. This would be the primitive approach, and you would be still searching, but you could also search for a brain that would solve this problem in a space of all possible brains. So what I'm saying is that this search can be misleading because it can lead to discovering new intelligences itself. It's not like this approach when you are just looking for a specific path or specific cycle in some set of points or locations. Okay, so this is where we finish. And this is why we will start our course in artificial intelligence from optimization, this field of optimization. This is very important to have this ground of optimization because, as you can see, most problems can be expressed or can be thought of as optimization problems. And first we will speak about complexity. Is it possible for a computer, even though it is so fast, is it possible to actually find those solutions if there are so many solutions in the set? Okay, so optimization, search, this will be the topic of our next lecture.